Hey, welcome you guys to today's live, and today we are going to start, I guess, OpenGL, and OpenGL is actually a very interesting topic. So it's not something very fundamental to JavaScript, but it's actually like if you are interested in graphics and all, like, yeah, so drawing graphics basically. I think they do WebGL, I guess, and Canvas, WebGL and Canvas. Sorry. So, yep. The browser contains some very powerful graphics performing programming tools from scalable vector graphics (SVG) language to APIs for drawing canvas element. See Canvas API and WebGL. The article provides an introduction to Canvas and further resources to allow you to learn more. Exactly. So, and that's our goal to for these technologies to understand, like have a basic understanding about them, so we can in future, if we require to make something that we know will use this, then we can ramp that skill up and um, go with it. So I wanted to cover this like properly with all my energy, and that's why I chose like today there to be that day. And yesterday I didn't stream, and I think we'll have fun. As we talked about in an HTML multimedia and embedding module, the web was originally just text, which was very boring. Then image tags came, and we had properties like background image. This, however, was not enough. While you could use CSS and JavaScript to animate and otherwise manipulate SVG images, and they are represented by markup, there still was no way to do the same for bitmap images. What's bitmap images? Collection of pixels. The tools available were uh, limited. Web still had no way to effectively create animation, games, 3D scenes, and other requirements commonly handled by low-level languages such as C++ and Java. Java also has okay. I when I think of Java, I usually think it as a server programming language because, but obviously very my extent of knowledge is also not like as good as the people writing this, but in my limited understanding, I see it as a server programming language. I see, though it does like a lot of web applications are also made in Java and XML. I have seen those, so yeah, so I understand how they could. It also must have a feature. Yeah, so the situation started to improve when the browser began to support Canvas element associated with Canvas API in 2004. As you will see below, Canvas provides some useful tools to create 2D animation, games, data visualization, and other types of animation, especially when combined with some uh, other APIs and platform provided, but can be difficult for or impossible to make accessible. The below example, yeah, we made this. I'll show you. So they created a canvas and with an hive, and then they created random balls, and so like this, and then they were moving the balls in request animation frame, I guess. Yeah, request animation frame, they were moving the balls. Basically, it looks like these balls get a lot faster as I scroll down. Uh, don't you think? Uh, yeah, around 2006 2007, Mozilla started working in experimental 3D canvas implementation. This became WebGL, which gained traction amongst browser vendors and was standardized around 2009 2010. WebGL allowed you to create real 3D graphics inside your web browser, and below example shows you simple rotational WebGL cube. it actually gets faster when it's not in a lot of frame. Like this is faster and it becomes slower. So I think must have done something. But why? I don't understand why. Because or it might be a quirk that uh, is in the implementation of WebGL. So this article will focus mainly on 2D canvas as raw WebGL code is very complex. We will, however, show you how to use WebGL library to create 3D scenes more easily. You can find tutorial covering raw WebGL elsewhere. Getting started. Let's just see. Okay, so WebGL is itself a very active learning. Getting started with Canvas. If you want to create a 2D, 3D scene on web page, you need to start with the HTML canvas element. The element is used to define the area on the page which is the image will be drawn. This is simple as including as like you include the canvas like this. This will create canvas on the page with the size of 32 pixels and you should some fallback content inside canvas tag. This should describe the canvas content to users, the browsers that don't support canvas or users of screen readers. Okay, so accessibility feature. So we must provide a fallback. For example, if you are rendering a constantly updating graph of stock prices, the fallback should be static images of then stock graph with all text saying that the prices are in text or list of links individual stock page. Canvas context is not accessible to screen readers. Include descriptive text as well as ARIA label. What's the full form of ARIA? It's ARIA. Yeah, ARIA. I think I remember that it was a shop. Accessible rich internet applications. Okay. Creating the size of and sizing our canvas. Let's start by creating our own canvas that we draw future experience to make a local copy of. Let's just copy this. Mm, okay, and what I have to do. I forgot the name of the project. What was it? JavaScript docs. Yeah. So we have an index page, index script and style, index control V. Let's delete all these. Oh, I deleted the index also. Yeah, it's okay. Let's just copy style. Empty. Cool. Open this and add the following code on into it. just below the opening. So we add this canvas. Let's go live. So it will be easier to see. Yeah. If you want better, but we will set them using JavaScript in the section. So canvas. Now what we are doing, we are setting it to the window height and width. Uh, they didn't ask us to add the script or JS file. Okay, they have added it. Okay, they are added and deferred it. That's actually a better syntax than rather than putting it in the body. We did this in earlier videos, and why was it better? Um, because it loads the JavaScript and reverses its loading. So it no, so asynchronously loads it. Async loads is just defer. Okay, so the board to start the loading, and in if it's in the end of the body, it will just render the HTML first and then start the loading itself. Yes, we have stored the canvas reference and we are uh, adding its inner height, inner everything. Okay, so getting canvas context and filling it with black color. Uh, so black color and yeah, so basically black color. Yep, full black. So what we are doing basically, we are setting up the fill style, and then we are making a rectangle that starts from 0x0y and goes to width, the value of this width x and width y. Uh, that's what I understand, I guess. Like its width is width and its height is height basically. Start from xy00 and all goes to or like its width is width and height is height. As we said before, all drawing operations are done with the management canvas and context 2D object. In our case, CTX, many operations need to give coordinates and pinpoint exactly. And drawing shape has to be done using rectangle shape primitive or use simple rectangles. Yes, we are making a new rectangle from 50-50 to width of 100 and 100 rectangle. And another rectangle You can draw semi-transparent graphic by so we can also draw semi-transparent graphics by using the RGBA colors like this. Uh, Now we can add a stroke, basically a line. I think we will have to add it before the, like making the stroke exactly. So if I add it afterwards, I don't think it will help us a lot. Yeah, it doesn't. So we set up the context and then we draw. Basically, that's as simple as it gets. So like the turtle, we can also draw paths, I guess. Uh, so a red color, begin path, move to 50-50. Let's just read. If you want to draw anything more complex than a rectangle, you need to draw a path. Basically involves sliding code, decimal, etc. Okay. Begin path starts drawing a path at a point where the pen currently is on canvas or on a new canvas starts to 0. So currently where's the pen? In my opinion, it should be somewhere here. If I have you getting, can we inspect this? I'm not sure if you can inspect the canvas. Yeah, that's very sad. Ah, so they're filling with red color, but I don't see anything. So where is it? Like if I comment this out, no, I don't see it. Let's make it black. I don't see it. Okay. So we are not actually drawing anything because for we had to draw it here and we didn't do anything. Now I'll not attempt to draw because it's very we have to use the stroke function to draw the outline of the shape. So I think it's like the turtle game that we used to have in older like uh, turtle coding, graphics coding that we used to do when we were kids. I don't know if everybody would have done that, but basically it's something like that they have. Uh, Turtle graphics. The no, tur- Turtle. exactly. So, mhm. Yeah, so there was this coding language that could help us write like such graphics we could make, and it was fun. Though at that time I like we had tests on it, and I dreaded this topic, but when I remember back to that those days, it was actually very fun making these. And we also in friends itself we used to compete like who can make uh, some interesting stuff, and it was actually interesting, like good to fun. It's a good days. uh, let's draw an equilateral triangle on the canvas. First of all, okay, let's just comment out everything for now. We'll copy paste and we'll try to explain the code, try to understand the code. Yep. So what we are doing, we are creating a function that converts degrees to radians, and then uh, we are adding a fill style. So we are adding color red to it. We are beginning the path. We are moving it to 50-50. So this must be 50-50. So what move2 does, it does not uh, create like it does not uh, basically it just lifts the pen and moves. So I, I'll take some um, references from the turtle. So turtle had two options where it could lift the pen and move, and one where it didn't lift the pen, and basically the uh, turtle could so yeah so, uh, whatever. So you get the point. So uh, move to just lifts the pen and comes to 50-50. Line 2 makes a line from 50-50 to 150-50. Then we calculate the triangle's height when we make a line to that, and then we go back to 50-50. So, and then we fill. One of the basic numeric formulas. Yeah, drawing circles. We create an arc. Take 6 parameters. The first to specify the position of the arc center. So this is the center. The third is the circle's radius, so 50 radius. And the fourth and the fifth are the start angles and the end angles. And the sixth parameter decide whether the circle should be drawn clockwise or counterclockwise. It makes some sense, but it doesn't. Yeah, okay. I get why they want to do that, because uh, let's say we want a circle to be 60 degrees up, so that's counterclockwise. But if we want a circle to be drawn 60 degrees below, then it's clockwise. So I get okay. False is counterclockwise. Another arc, 45 to 45. Uh, it's this one. Pac-Man. Okay. So we can also fill text into it, and it will look something like this. Drawing images onto the canvas. We can add new images also. And okay, so what they are learning, I think there's some asynchronous operation with the middle. As before, make another fresh copy image your SRC or image, but there's so uh, only part of that. So we can do both in complex. So the raw image has like a lot of other complex overloading also. Okay, loops and animations. We have so far. It's actually very interesting. And it's also kind of now nostalgic for me because I remember the turtle game and it was fun. But yeah, it's good. Uh, we have so far covered some very basic 2D canvas, but really you won't experience the full power of canvas unless you update or animate in some way. After all, canvas thus provides control images. If you aren't going to change anything, you might as well use static image and save yourself all the work. Creating a loop. So for loop, playing loops in canvas in remember you can run canvas commands for inside for or other type of loop just like JavaScript code. Let's build a simple example. Make another fresh copy of canvas on one canvas template and open it in your code. Okay, so this looks interesting. I should just clone it. Can't I clone just a file of it? I thought I could. Sad. How do I download this? Save image. Yeah, but I hope for a better way, but okay. This is not bad. Uh, Style is the same. Script basically the initial stuff so be the same. Yep. Sure. Hmm. Add the following line at the bottom of your this content. So we are translating the. I should move. Which moves the origin point of the canvas, so it should come to the center. So let's just predict what it's doing. We are creating a function. We are creating random max random. Right. Okay, so it's actually doing nothing. So okay. Uh, yeah, we're just implementing some functions. Yeah, that will draw something. For okay. Now we'll predict. What's it doing? I don't know why my format is not working. I it like these. It works in React. This has not been an issue because I don't generally write vanilla code, so I have not cared enough to test it. But like I think I'll fix it sometime. So we are taking a fill style, which we are. Uh, so basically five now. This is five, and this is also five. 505 019. Begin path. Move to. So move offset. Move offs. Where's move offset defined? Okay, move offset is this, and land to plus land. So we are making a line to that. And okay, cool. Basically, it's making random triangles, I guess. Yep, it's actually this looks nice. Wow, I can make it my wallpaper. Like I like these whirlpool like structures. Though I love these Ventura wallpaper. This one, it's so on age iteration. We say now draw rectangles are cool animations. Oh, someone really we need to concept low. Uh, 1 minute. So, I want to try something. Where are we using I? Are they using I anywhere? Control. No, they don't seem to be using I. Does this work? Nope, it does not. Why doesn't it work? So third law. So every 2 seconds, it's consoling and logging. Okay, we have length. Begin path. Move to move offset. Line to offset. I The code does not seem wrong to. Okay, it's very slow. It's actually very slow. Let's make it 10 times faster. Let's make it 100 times faster. Ooh. We are great. I was born to be a genius. Thumbs up. It's actually really interesting. So we can also do it in request and infringement frame. So we can do it like this. Const f equals to it only takes a callback function. So yep. So why isn't it working? Okay, it works like this. So I'll put this inside this function, I guess, and I'll call in s. This happens on every frame, so it's very optimized, and it's good stuff. I'm actually very happy. Complexity such as making animation run at consistent speed and not wasting resources and everything. To see how it works, let's quickly look again at bouncing ball example. So we remember the bouncing ball examples and how it we created a loop. So and we also saw it in at the start. So cool, simple character animation. Let's create a fresh copy. So we have this. We have this. Uh, Only two changes, I guess. Index. Index also is the same. Only one change. Change. Split. Split. So update the inner estimate to reflect theme. Yeah. Uh, we know it's a good accessibility feature, but currently it's not our main goal. Uh, in the production application, we must actually use this properly. But currently, we'll just stick to learning and drag. We are creating a new image and image on load. So, like instead of adding whole image event listener, we are just uh, using the onload. Where's the draw function? Let's just continue working on it. Now let's add some waivers to track the position of the sprite. Okay, we are now making the draw function. Uh, we are making a rectangle of minus width by 2 and which starts from the center and goes to height and width. Then we are drawing the image and we are using like complex arguments to like all these arguments to basically set up the position of x-axis and then um, where to cut it, basically the cropping and all. So now we are altering the value of pos x after each draw. We are changing the pos x. Now we are adding the request animation frame. Exactly. So let's go through the code. So basically we are selecting the image, we are adding the src, we are adding the draw function that we declare later on, and this is actually the draw function is hoisted upwards. That's why we are able to access that. And then we are creating a function called sprite and posx. Um, then we want to start the image from the center, so you can see it starts from somewhere. So We are creating a rectangle from the center, and we are drawing the image edge, and then we are changing the POSIX and sprite accordingly. So and we are like looping it, and then we are calling the function again and again using request animation frame. A simple drawing application. The final animation example, we would like to show you a very simple drawing application to illustrate how the animation loop can be combined with user input like mouse in movement. In case we won't get you to walk through the build this one, we just explore the more interesting parts of the code. Example can be okay. What is it actually? I don't understand. Oh, cool. Ooh, mouse move over on mouse down, and then we actually add, basically we are adding circles, uh, all these events. Now let's do WebGL. So how big is this? It's actually a decent size, like normal size. It's now time to leave behind 2D behind and take quick look at 3D canvas. 3D canvas contents are specified using WebGL API, which is completely separate API from 2D canvas API, even though they would render onto canvas elements. WebGL is based on OpenGL, Open Graphics Library. OpenGL is, I guess, in C++. WebGL is like very popular. I think Vulkan. I've heard Vulkan as a competitor of OpenGL. Like that's C++. Using a library because of its complexity. Most people write 3D graphics code using. So 3JS, Play Canvas, and they Play Canvas. Basically, I know 3JS. 3JS is quite popular. Play Canvas. Oh, it also does have good stuff. A lot of like, don't be very uh, daunted by all these images. These all images are made in different softwares and then used in like uh, like how we saw this image was made in, like, this was an image then used in this website site that, like, similarly all those graphics are made in some other software. um, we create the queue. Let's look at simple example how to create something with OpenGL library. We use 3ds. 3ds is the most popular library that I have. I had only heard of 3ds before this. Now I know Play Canvas and Babylon JS something. 3ds. I thought they'll go in deeper into um, WebGL and not use 3ds, but it's okay. Nope. Total files. Do we have only one index? So let's remove all these images. Can't we find a CDN? I guess I don't want to download 3GS right now, so I guess we have seen the working demo upwards, and I think we'll just go and this is the working demo. This one. So I guess we'll go and just look at the code and how it's working. So we download 3GS, we make a scene, so new 3GS scene, we add a camera, so new 3GS perspective cameras, and what are properties that's there? Field of view, so 75 degrees, aspect ratio, uh, near plane, how close the camera objects can be before we start rendering them onto the scene. Think about how when you move your fingertips closer and closer to the space between your eyes, eventually you can't see anything. Exactly. So at this point, I can't see my finger. Like at a point, you will not be able to see your fingertip, and so and it's actually very painful to do this. My head's like kind of drowsy. The far pain. So basically, we also set the camera position to be distance 5 units from the z-axis. We create a new renderer, we set the size of the renderer, and we append it on the document. The first line creates a new, yeah. We wanted to create a cube. We create a cube loader. These are 3GS properties. It's good that they are showing it, but uh, I don't find a lot of use of this. It's a very interesting topic, but if you want to learn it properly, and don't just like download a Udemy course. I actually have a 3GS Udemy course that I have already downloaded, and I would like to learn it, but like I have much important things to learn right now, so I haven't focused a lot on that. Um, Currently, I'm learning like MySQL properly, and on Udemy itself. So I've done like 80% of that course. So I think uh, for me right now as a developer, I'm not at that stage where I have that leisure time to learn stuff that are cool, but in India especially, I don't find a lot of demand for that. Basically, they'll come to this, and it's interesting how 3ds works, and you can like they are at last you are rendering a rotation, and you are rendering a cube, you are rendering ring like the six sides. Yes, the six sides of the cube, and uh, so it's cool, and you are providing information on lighting and all that. So I guess this marks the end of today's session, and yeah, I no, I wasn't seeing my stream, so I thought I actually did not stream, and that would have been horrible. So, what did we do today? Drawing canvas, drawing graphics. I don't think this will fit. it doesn't. So, did anybody join the discussion? No, I don't think so. Yeah, I hope I am not spelling it wrong. SQL, thanks. Um, uh, I should find better ways to manage my chat. Uh, I don't have that kind of setup now where I can make a screen. Like I don't have a second screen. What generally those streamers do, they make use of a second screen. Uh, but I'll try to figure something out. Probably, I don't want it to take a lot of screen real estate. Uh, okay, but here I see space. I see space here, so I guess that would I can put it here, and uh, that would not be a problem. Let's just I'll find how to do that, how to add chat, and I guess from the next session we'll have proper chats. Uh, Thank you guys. Thank you Ezekiel for joining. Bye bye.